your collaborative work with Louis started a long time ago.
Yes.
And it lasted for a long time.
It
So
lasted
maybe
for a long time.
you would like to elaborate a little bit about from the beginning of Louis.
Well, I must say I first heard of Louis from Hans Levy. Levy had visited the University of Minnesota, where
There
Louis
is some
was an
work
instructor.
also, you were talking about
Louis
nonlinear
attended
quotient
Levy's
Kowalski
lectures
on fully
and then
nonlinear
approached
problems
Levy
you've
and
done with
said,
Caffarelli.
could you tell me some open problems?
Okay, maybe you want to give us
Brooke and I wrote a
Which
whole
he
series
did,
of
and then,
papers on
to Levy's astonishment, Caffarelli came up with solutions to these long-standing open problems. So Levy was very impressed, told me about Louis, and then I urged that we hire him at Courant, and he came, and we began to collaborate on different problems. All of them are nonlinear problems. They have to do with existence theorems, difficult estimates. He has fantastic intuition, Louis. He sees things that I don't see, and he's extremely fast. So sometimes I had trouble keeping up with him. And that apparently is a common experience of people who work with him. He would write something on the board and not enough for me to understand. So I would say, Louis, please write more, write more. So he would write a little more. And finally I used a sort of biblical expression, Louis, where is it written? But it was enormous pleasure to work with him. The guy is so talented. It's just, but I've had many talented collaborators. It's just been a great joy.
Your work with Louis, did it start with the Monchampere or something else?
I think it started with Monchampere, with Spruck.
With Spruck.
Yeah. I had worked on Monchampere with Calabi some years before and thought we had proved a theorem.
Yes.
And one day Pfefferman came to me. We hadn't published anything. Pfefferman came and said, can you show me how you prove the estimates? So I showed him proof of some estimates. And then he said, how do you get the lower bounds? And then I realized I didn't know how to do it. We hadn't done it. And then I spent years just working on that and got nowhere. And then Louis and Spruck began to work on the problem, and I joined them. And we solved it by not getting those lower bound estimates, but different estimates.
And are these lower bounds estimates known to be true or
Yes,
not? Still not known?
No, once you have the different estimates,
then
it
you
follows
have
from
that
general
particular-
theory. Yeah. So that was the first paper. And then we wrote a number of other papers on nonlinear equations, fully nonlinear equations. Yeah. And then with Berezticki, we wrote on so-called semi-linear equations,
Right.
several papers.
Right. You also worked about the De Giorgi problem with Berezticki?
In 2 dimensions we had solved it, but it had been solved by others. The problem we worked on was similar to the Giorgi problem, and there's still an open question there. In n dimensions in the upper half space, that means xn is positive. You're looking at a function u which is positive and bounded by some, let's say the least upper bound is a number m.
Okay.
And it vanishes on xn equals 0 and satisfies an equation of Laplacian u plus f of u equals 0. And the theorem we proved is that if f at the value m, the maximum of u, is less than or equal to 0, if I have the sign correct, then the solution depends only on xn.
Oh, right.
And I've tried for a long time to show that necessarily, if there is a solution, f of m has to be less than or equal to 0. But I haven't succeeded. And a number of other people have tried it and haven't succeeded. Still an open problem. Simple sounding open problem.